right. Good afternoon again. Lunch? Yeah. I know, it's like this. This year, one of my sessions was just before lunch, and the second session is just after lunch. Both are kind of difficult to manage, but let's do it anyway. So my name is Ravikanth. I'm going to talk about a framework that's basically that I've been designing and implementing for my own purpose, but I'm going to open source that pretty soon, which is about a distributed, flexible validation framework, operations validation framework. So how many of you actually test in production? Not that the code that you write in production, but you do, right? Tests in production are basically very useful when you really want to make sure that the configurations that you're deploying in the production are really functional, right? Nothing breaking as such. I mean, with respect to when I deployed a configuration, for example, like for a VM switch or some kind of an RDMA configuration, etc., I really want to make sure that the functionality itself is still intact and it's not broken. And the configuration that is intention was, it's actually delivering that result as well. Now, there are multiple ways to do that. We will look at that in detail. What you learn in this session is not just about how you can actually create something like this, but what are the different considerations of the design goals that I had when I started this whole project, and how it basically overcomes some of the issues or the limitations of other frameworks that are there. So that's the agenda. We'll talk about why there's a new framework, why is that needed really, and then look at the architecture of the new framework itself, and we'll go into the demos. Very few slides I have. Right, so if you take the current scenario, this is something that I have, right? I mean, you have a test controller or a management system from where you're basically running all the operation validation tests, and you have a bunch of nodes. You execute the test. In this case, these are all pester tests, right? So each of them having some kind of a configuration data. You pack that with the pester test. Test runs on the remote system, I mean, sitting on your local console. And then you get the results back from pester, and you process those results. That's basically creating reports like HTML reports or Excel files and so on. Now, the problem with this method is the tests are all centralized on the controller, number one thing. The second, as the tests run on the remote system, you have limitations there. Now, many of my tests basically use remoting, and they get to talk to other systems in the network as they run on the second node. Now, that kind of introduces a second hop issue, right? The credentials that won't be delegated from the first system to the second system, and then any connections from the second system to any of the third system in the infrastructure will definitely fail with an access denied unless I enable kind of a credential SSP delegation and so on. That's the first thing. Now, there are goals that I had in mind where I really wanted to create. How many of you have seen Windows Admin Center or used in Windows Admin Center? Okay. The ultimate goal of this entire project was to create a Windows Admin Center extension using which I can actually deploy these tests onto the target systems and then have those results visualized per server within Windows Admin Center itself. Now for that, if I have everything centralized, I would lose the context of running things on the remote system, having the results there and populating per server kind of that kind of a capability will be lost. So one of the other important goals that I had was to enable that, right? Wanted to really have those results cached for a long time on the target node and have Windows Admin Center query those results and visualize that for me within the Windows Admin Center console. Now, how we're going to change that, this kind of architecture limitations into something new is I have a test controller which basically publishes test packages now to the target nodes. And so once the target node has these test packages, we execute the test on the remote node per node basis. There's no test controller that gets involved in executing those tests. There will be scheduled tasks that you can actually use to run these tests on a regular basis. And then using the test controller, I can actually retrieve those results back into the test controller and process those results for any reporting purposes, etc. So I have HTML and Excel reporting and so on, right? Any questions so far on this? on the goals itself. Is it clear? Sure. So what exists today? You have DBHX, must have seen many sessions here talking about DBHX and Pester and so on. DBHX follows that model of a centralized text execution. So you have all the tests on the local system. I just target it to a SQL instance or a target node. Everything runs from the local system on the to targeting the remote instances and then gives me results back. P80 checks AD, what Matthews is working on that he demoed yesterday. That also has a similar functionality where all the tests are local and it runs from the local system onto the remote system. In a distributed manner, if you actually see, Microsoft OVF has some way of doing these things. If you go look at the operations validation framework project, it combines the tests along with the PowerShell modules. As PowerShell modules, you can actually package all the tests and invoke them on the local system, on the target system directly. So all the tests are now distributed against multiple target nodes. But it lacks the ability to provide configuration data. Now, all of my tests are kind of specific to the infrastructure or the application that is running on my target infrastructure, but the tests are common, reusable tests that I have. So if I cannot have the ability to kind of separate the configuration data from the test, then I don't have really the flexibility that I desired there. PS Health, again, is kind of a web services wrapper on top of operations validation framework. It provides a web service on the target nodes through which you can actually invoke tests remotely. Now, the tests are distributed. You're actually invoking the test remotely, but again, the same limitation of not having a separation between the configuration data and the test, the code that is actually performing the test execution is not desired actually. So that has to be there. The separation has to be there. So looking at these two, a couple of years ago, we developed something called PS Remotely. PS Remotely, again, very similar to the way you run Pester, but it can be targeted to a remote system using PowerShell remoting. It's purely based on PowerShell remoting. When you use PS Remotely framework, it will basically distribute the tests on its own to all the target nodes using invoke command and the other remote file copy procedures using remoting. And then it invokes the tests on the remote system itself. And the results are collected automatically and kind of combined at the test controller space. Once again, you'll run into issues of second hop with the remoting. So there's actually no way to work around that unless you implement CRED SSP again. So these are some of the limitations that kind of made me take a look at again some of these design goals that I had and come up with a different framework altogether. That's what I'm calling Garuda and Chakra. I'm sorry if you cannot pronounce those names. Garuda is a mythological bird in Hindu mythology, the Indian mythology. So it's a very powerful bird that can actually go anywhere. Okay, that's the test distribution part of my framework. The Chakra is the weapon of Lord Vishnu, and a very powerful weapon. It can do anything. It can destroy anything. It can construct anything, or anything for that matter. Right. So Garuda is the vehicle which basically sends these tests onto the target nodes. A test execution engine, which is sitting on the remote systems, is the Chakra engine. All right. So enough GAN there. Let's go. Let's look at this architecture now. So this is the architecture. So this is, again, familiar to what the design goals that I had, right? Garuda is my test controller, which will basically publish all the tests. And it will also create, as a part of publish process, it will create scheduled tasks that you can actually trigger at a certain period of the day or how many ever times you want. Chakra basically is the engine that actually gets triggered every time the schedule task opens up. So I also have a simple web service there, which will basically today serve as a way for me to retrieve the test results from the target nodes and then process those results at the test control level. Okay. Now, since this is based on DSC, the way publish tests really work is I auto-generate a DSC configuration for whatever dependent modules that are required and the dependent DSC resources that are required. We put everything in a module repository, which is a NuGet repository locally, which is just a SMB share. I'll show you that. Our pull server, again, SMB share. So once I publish this configuration onto the target nodes, they pull out all the dependent necessary modules that are required to enact this configuration and do the job. Okay, we'll see that now. Any questions on this? All right. And I spent this morning a couple of hours designing that logo. All right. So I finished my demos, I finished my slides, I kind of was free, so I developed this. Let's look at the demo now. All right, so the first thing is I have this module called Garuda here. I'm just loading that. Can you all see it clearly there? Or should I increase a bit more? Okay. Is that good? All right. So this has a bunch of commands. Now the essential aspect of this whole thing is packaging the tests that I have into a set of groups. Okay. Now, given an infrastructure, let's say I'm an infrastructure guy, I'm developing S2D architectures, I mean the storage spaces direct, software-defined storage architectures. I'm responsible only for the infrastructure layer. Now there's someone else like Bartek, maybe he's responsible for running a workload on top of that, like SQL or Exchange or whatever. Now he has his own set of tests, I have my own set of tests. Now we don't want to conflict with each other. What I can essentially do is I can create my own group of tests, publish them. He'll create his own group of tests, publish them. Everything has its own schedule that it runs, basically. Every test group has its own schedule as a scheduled task. And now the results are also now standalone for that particular test group. So the way we achieve that is, if you see this, I have a library of tests here. I don't think you can all see it, see this there. But I have a library of tests basically for different purposes in this case, right? Now, once I have those tests, I basically create a test parameter manifest, which will basically tell me what are all the parameters that are needed for that particular test to execute. Are there mandatory parameters, or are there parameters with default values, etc.? We capture the entire metadata for each of those test parameters that are needed. Now, it's very easy to add new tests. All you have to do is really copy if you create any new pester tests with parameters and so on into this folder, and then run this command. Run this command called update Garuda test parameter, right? So when I run this, what it essentially does is it uses some AST and then generates the parameter file. Okay. Now this is just a JSON which basically per test, what are all the different parameters that I need? For example, there's a cluster test script that I have, which has cluster name as a parameter. It's a mandatory parameter, if you look at the parameter metadata there. And other things like, is there a default value and so on, what type of a parameter it is, etc. Now, where I use this, I'll basically show that in a bit. I'm also using kind of parameter sets here. Every test parameter has a parameter set also. Think of like, all of you understand the pester test tags and so on, right? Now, the test tags are basically used to invoke only a specific set of tests within a test script. Similarly, I correlate these parameter set names to tags within my tests. So at any point in time, if you want to execute, your idea is to execute only a set of tests within a bunch of test scripts you have, you can actually specify that as well. So now there are different layers of abstraction here. You can combine your different tests into a test group and then also filter within the test group based on the tags that you have for pester tests. So you have flexibility in terms of what you really want to run on the target systems. So similar to that, you can actually see this for every test that I have these different parameters shown here. Now this is one-time job. You can actually put it as a part of your build scripts also. So every time you add new tests, your build script automatically builds this parameter JSON for you. You don't have to manually do that. So now how you create a test group is again simple here. if you look at this, so I have a command called new Garuda test group. We just give it a name, and then you specify a description. It will automatically pick up the test and give you a list of things that you can add. Okay. This is done using dynamic parameters. So whatever tests that are available already within the testlib folder, it will actually parse that, use the name of the file as an input parameter here. So I have that. Let me just run this. Test group already exists. So I've done that, I think, this morning. We kind of store that information as well within the a JSON file called testgroup.json. So if you take a look at this file here, it has like 3 test groups already within my framework. So I have one for the cluster test that I want to run. There's one psconfig test that I have been testing for a while. There's just one this morning I created, or using the command that we've created that. Right. So now what it basically has is a name, description, and a set of tests as a part of that group. That's it. No other metadata information here. Everything else comes from testparameters.json when I want to really enact any of these tests. Now, one step before you actually publish this test is to generate a parameter manifest itself. I mean, now you know what test that you want to execute on the remote system, but you need to give the configuration data also for those tests, right? The configuration data is basically the input parameters required for those tests to run on the remote system. That's done using the get Garuda test group parameter command. You just give it a group name that you already created and a save as parameter, which basically saves it to a JSON file. So this is done. Let's quickly open this up and see. Yeah, it's just a JSON file got created. I think, let me just add a few values here. If you actually see the way it is structured also, for example, computer name parameter in the test is a string array. So the manifest also kind of changes that. It gives you the indication that, for example, the moment you see anything within square brackets, it's an array within JSON. So it correlates the information that you actually have in the parameters sets or the parameters for the test and uses that information to build this. There are definitely certain improvements that I can actually do, like the credentials that you see down there. Today it's plain text. Just on this, right? Just before you publish, until you publish these tests onto the remote system, these credentials exist in plain text today. But the idea that I have is to kind of use a local credential vault and then make you basically input those credentials as an input parameter, than putting everything in the manifest. This is not secure for sure, but I think for a version 00001, I think this is okay, right? Let me just input a few more things and make sure we can actually enact this. I'm not giving you the details of what exactly the tests are doing within the test group, but if you actually look at, probably some of you who are familiar with any of these things here, and the catalog way of doing things, I can now validate the whole system for its firmware compliance also. Yeah, we have the capability now through different out-of-band interfaces. I can talk to the remote system, validate it against an update catalog for the server. So I can validate for a specific BIOS level or the firmware level for a NIC and so on. I can also validate the operating system for desired driver versions and so on. That's the catalog that we have here. So now I have updated that. What I'm going to do is create a test group package. That's done using the publish Garuda test package command. So, like I said, this is the one that actually generates DSC configuration automatically based on the input parameters. So in this case, I have a test group. I have credentials required as a part of my test execution. Now, what happens to the credentials on the target system is that using Windows Credential Manager, we create these credentials as a part of a vault. And then the Chakra test engine, which is aware of the test parameters, the moment it sees a credential kind of a parameter, it will actually look for a similar thing in the vault and pick up the credentials from there. Right? So the basic idea is that the tests on the remote system run without any interaction at all, without any interactive need for it. Right? I don't have to really input any parameters on the target system. Everything, including the secure strings and all the sensitive data, is actually put into a credential vault, and then you basically use that for retrieving the input parameters. The only thing is whatever non-sensitive today, like if the parameter is a string or an integer or something like that, it actually still lies in a JSON file on the remote system. The Chakra engine basically reads the JSON for those parameters, and for any other encrypted stuff, it will go read the credential vault. So this is what I have, some parameters there. I'm saying do not enact because I really want to show you guys how the generated config.ps1 will be. Let's see that. So it has generated a configuration script, a DSC configuration script. What is the shortcut to format a document here? Yeah, got it.
You have the txt extension.
No, I have a .ps1. It's actually formatting. Yeah, okay, cool. So this is an auto-generated configuration document, right? So it has all the required DSC modules. For managing the credentials, I'm using something called a Granny resource. It's a community PowerShell DSC resource module, which gives me the capability to work with the credential manager in Windows and then add credentials to the local vault. I'm using PowerShell get because there are a few PowerShell modules that I need to push as well. For example, most of my tests are dependent on tester 4.8.1, so I don't want systems to have anything else. They just should have 4.8.1. So I publish all of them to a local PowerShell repository and then pull them using the PowerShell get module. Computer management DSC is being used for creating scheduled tasks on the remote system. And that's it. PS desired state configuration has to be there always. Right? So the first thing you have is a repository. We create that repository on the local remote system. I think we did a mistake there. Did a mistake here. I'm using the same thing here. This should be ideally name. Let's regenerate it. Okay, so we have this again. If you look at we first register the PowerShell module repository on the remote system, and then we install the modules that are required. I'm using Polaris for creating that endpoint, which basically gives me the results. And I have a test library, which I basically copy onto the remote system. The test library will now contain anything that is needed for this particular test group that you specified, right? In this case, psconf view test. I have a set of test scripts that are as a part of the test library. I'm only copying what is needed onto the remote system. And this is the credential manager. This will go now create those credentials in the credential vault so that I don't have to expose the plain text credentials anywhere. And it then creates a scheduled task. So one thing that's not really probably explicit in this thing is you can have any number of test groups sent to a system. Okay. Now, when I'm actually publishing, I can do multiple publish tasks. I'll do it once, and Bartek will do it next. But for every of those test groups, we can actually create a separate scheduled task. To create a separate scheduled task so that I have control over when my tests actually run. So I might want to run all my tests every midnight at 12 o'clock, but someone else might want to do it at morning 5 o'clock or 6 o'clock, right? So they can have their own schedule for those test parameters and the test scripts, and I have my own stuff, right? Now, if you really want to change any other parameters, for example, I don't have the recurrence, etc. in this. Since this is a configuration script, a DSC configuration script, you can go at any point in time, change that, and add those other parameters like recurrence and so on. But that's one of the other to-do list items I have where I want to really give flexibility in terms of configuring the scheduled tasks and overall the Chakra test engine itself. For example, today the Polaris instance basically runs at port 8080. You should be able to customize that as well and run it at a different port or with HTTPS and so on. This is the configuration data. One of the things that will change is this. Today, since I'm not using the credentials directly within the test script itself, I'm actually just putting PSDIC allow plaintext password, but which is not right. I should be ideally using certificates to do the right way of enacting credentials on the remote system. So this is where we are creating using the plaintext password, we're creating the credentials for both IDRAC and the catalog. And then finally, we create this configuration morph. This automatically generates a configuration morph. Now I can simply execute this if you really see that. If I execute this, it will basically generate the configuration morph. Okay. So far, so good? Clear? Okay. Now it's just a matter of enacting this, right? I have a pull server configured on the remote nodes, which will automatically pull all the dependent resources. I have a PowerShell module repository where all the dependent PowerShell modules, not the DSC resources, are kept. So anything that is needed within the DSC configuration or for the test to execute, it will automatically get pulled from the local PowerShell repository as well. So there are absolutely no other external dependencies in this case. So going back to the demo, let's see. If I go to the target node, I have, you see that psconfu test, that's a scheduled task that is created. I think I should have it on this also. So this has been there for a while now. The new one that we have is psconfu demo, that's a test group name. So once we enact this configuration, there should be another scheduled task out there. Let's try this.
It does not need name in there as well. Or
I'm sorry?
things just ran.
Huh? I didn't get
The fragment you had just there had whatever it was path and whatever it was path should not be named.
Did I? Yeah, sorry. So the question is, yeah, you're right. So the question was basically, there was a typo in the earlier script also, right? This has to be a name variable and not path variable. Let's enact it again. It's DSC. Yep. That's because the module repository exists with a different, the path exists with a different name. That's what it's complaining. It's a bug in the PowerShell get module DSC resources. So they don't, it's actually not a bug, I think. But it is like the module repository path exists, but with a different name, they don't enact it again. They basically error out saying that the module repository already exists there. But that shouldn't block us because we have already implemented it now. So if you actually see here, I have my new scheduled task created. This is for the different test group. Right. Yeah. Now, what really happens when I run these scheduled tasks, or run this test group manually on the system also is, I'm using program data for storing all the results. There's that Chakra folder. and I have these results set here. So any current result actually gets stored with a group name .current.json, and the older ones will be group name .timestamp of when the test was run .json. Right? So we kind of retain these test results for a long time. Now that's another parameter I want to add as a part of the Chakra configuration itself, where I will be able to now say retain these test results only for like 30 days. Beyond that, I don't need any of those test results. We should be able to control that as well. The test library gets copied to C:. Today again, there's no way you can configure that path where the test should be copied to. This is a Chakra engine. The results and result server.ps1 files are the web service that basically serves the results using Polaris. Chakra.ps1 is the test engine, which basically invokes the test. So if you look at this folder, there's a test parameters.json. This is the same manifest that you specified as a part of publish task. It gets copied onto the remote system. And then once the remote system has those, the Chakra engine comes up and basically reads that for any of the tests that it has to run as a part of the test group and filters only for that what is needed. It's a very pretty simple script, not much here. But if you see here, this is where we invoke Pester. Right. If you are using Pester 5 alpha or so, this won't work because Pester alpha 5.1 alpha, I think, removed -script parameter from invoke Pester. So you won't be able to splat the path and the script parameters to it directly. So you have to be somewhere in 4.6.1 to 4.8.1, I think, for this framework to actually work. Now, what the test results really contain is it's a dump of all the Pester results you basically get when you run Pester with a pass-through parameter. There's nothing here. The only additional information that we actually add is this, a test group name, so that we can actually identify what test group that the results belong to, and our timestamp of when it was run. It's basically, I think, MMDDYYY and the hours, minutes, and seconds. And this is the test within one of the tests within the test group. And these are the Pester test results from that. And I have another test within the group. There's a wrong way to look at Pester tests here. So there's another test here. So in this test group, I basically have two tests. One is related to numbers, one is related to strings. So, and the results you can actually see here. The total count within strings is two tests were there, one passed and one failed. Okay. Now, how do I get those results back? Like I said, there is a web server running. You can basically use the get Garuda test group result command, and then give it -computer name. It will actually go talk to that particular web service at the target node and then retrieve the results. By default, it gets you all the results related to, all current results related to any test group. If you can specify a specific test group, I think they have only one test group so far running there. So you get that results as well. Now, the reporting mechanism, yeah.
Credentials needed to get the test from the server?
Not today. Not today, because we are only doing read from the local file system. I have not put any authentication. The question is about, are we doing any credentials or using authentication for retrieving the test results? Not today, because all we are essentially doing is just a get on the local file system to get you the JSON object. But that's definitely one of the things in plan, where I can have either certificate-based authentication or a local integrated NTLM authentication as well. So that's all in the demo. Any questions here?
The test execute on the remote system. Are they each time copy over, or they stay there and if you need to update them, you just update them?
Yeah, so question is, are the tests copied every time they have to run, or do they stay there? They stay there on the remote system. It's a one-time publishing. But then if you want to update the test group, you can always publish it again, right? You won't lose the old results, but the new results, you may not be able to correlate because you've updated with more number of tests. But otherwise, the test results will stay as is. And if you don't have any need to update the test group itself, you can just keep running what is there on the remote system. Yes?
So you're using DSC to deploy the Chakra, but do you see any issues with deploying from a different configuration management system as long as you cover with dependencies?
I think you should be able to. The question is there a dependency on DSC itself, or can we use any other configuration management system for publishing these tests? Not necessarily. As long as let's say you can use the same, I think from a framework point of view, it is now tied a bit into DSC because I'm generating that as a part of a publish step. But if you can actually generate your own configuration for Ansible or Puppet or something, the rest of the thing stays as is. Yes?
The web service on each node that you fetch the results from, if you have host space firewall, can you configure the port, or can that piggyback on some other rule that's...
Yeah. So the question is, can we configure firewall rules for the web service which is running as a part of Chakra test engine? Absolutely, yes. We are using DSC. Anything is possible, as long as I have a DSC resource to do that, right? Now, let me just go show you some to-do. Relating to your question, for retrieving the results, I want to really do away with the web service way of doing things. I want to really implement a GI endpoint. Only thing that GI endpoint will be able to do is just get those results and nothing else. It will be loading the Chakra engine and then just get me the result object as a part of my GI call. That's it. So that's way more secure than using a web service there. I don't have to really depend on the external module also in that case, right?
So is it part of the design that the test result, the latest test results will always be available from the node? It's not like you're going to assemble them somewhere else centrally.
Yeah. So the question is, are the test results always available on the latest test results always available on the remote system? Yes. They're always lying in that C:\, program data folder. At any point in time, using any mechanism, you can actually go get those results. The only thing that the get Garuda test group result makes it easy is getting a specific test group results and nothing beyond that actually. Any other questions? Yes.
So this is a test management and execution and results retrieval framework. So it focuses on tests. But could this also be suitable as a generic scheduled tasks execution engine, management and execution engine?
I mean, the question is, can we use this as a generic schedule task management and execution engine? I think this is too big, bloated for it. All you really need is DSC in that case. You don't necessarily need the other aspects of the engine itself. Yeah. So, yeah.
Sorry. With regards to Windows Admin Center integration, do you think you'd retrieve results, like would you cache results, or would you retrieve them at runtime with the user's credentials in Windows Admin Center? Which is obviously the current like Windows Admin Center where everything's everything runs users. Right. And then is that what you would use here?
Yeah, I'm sorry, if I understand the question, it's about how Windows Admin Center can actually talk to the nodes, cache the results. So Windows Admin Center is real time. It does not have a local cache, right? But every server has its associated credentials. What I can do essentially is, in my extension is use the associated credentials and then just go talk to the server, get those results back. That's it. And it's real time. Every time you click on the server and this extension, it goes to the server, loads the results. That's how most of the Admin Center extensions work. Okay. All right. So coming to the list of things that I'm still working on, Windows Admin Center extension is definitely the priority one that I have at this point in time. Now, the way I retrieve the results or the way I'm caching the results or scheduling the management tasks, etc., is an internal concept for the engine really, right? It's not necessarily related to what is being exposed as a part of my extension. So the first top priority I have is to bring out that extension. I'm pretty lousy TypeScript programmer, so I'm still learning that. Most of these extensions are done in TypeScript. You have to follow the user interface SDK that these guys have and then build it in the right way. So I'm working on that. The second one, we have already talked about it. I want to really eliminate the need for plain text credentials anywhere in the system. So on the execution side, we already eliminated that using credential vault. But on the publish side also, I want to really use a local credential vault or something like interactive credentials instead of putting them into manifest and then using that manifest itself. That seems pretty easy, actually. Prompting for credentials instead of going through the script process is easy. I think we should be able to do that. I'll also add a few default reporting options. And since the very nature of the framework itself is that it gives you a JSON object of test results, you should be able to now bring in Power BI or anything else. But I'll definitely create an abstraction layer there that will give you the data that you need at any point in time. And a couple of examples of maybe using HTML and Excel reporting so that you can implement your plugin also the same way for whatever type of a reporting you want to really generate. So all the results will be of the same format. The interfaces to work with the results will be same. You define what you want to really do with the results in your own reporting method. Adding support for GIA, we talked about that. That also kind of an easy thing to target at this point in time. If you really don't want to use a Windows Admin Center extension, but you just want to retrieve the results and play with it, you should be able to then talk to a GIA endpoint, get those results, and start playing with it. Last thing is the Chakra custom configuration. Today, like I said, the web service always runs on port 8080. You don't have control over that. You don't have control over where the Chakra engine actually sits and copies all the test library files and so on. And also some more flexibility in terms of how many times you want to run this test. Today, it runs every day at 12 o'clock in the midnight. You don't have control over that unless you edit the configuration document before you enact. So want to create some more flexibility there so that you should be able to kind of bring in those parameters as well into the overall publishing system. All right, so let me do the honors here. I'll just publish it before you folks. So I'm making the repository public now. If you guys want to really play with it, do it at your own risk. It works. It works, but it's pretty very, very initial design. So
You said it's a weapon.
it's a weapon. Yes. Be careful. I hope I remember the password. All right, that's public now. So thank you. Right. So the slides for this session and the demo code will be available there. You can actually download it off the PSConf.eu GitHub repository. Any questions? Yes.
What's the main purpose of those tests? I mean, this is quite a big framework for having some tests, and especially additionally adding some web server to each node. So in the realm of like 100 servers, you would have 100 web servers in each node just to gather the results. Can we leave the web server off and just stay with the JSON on the server and then somehow else boost data?
Yeah, the question is, can we kind of leave the web server because let's say he wants to run these tests on 100 different nodes and there are 100 different web servers now running in the infrastructure? Pretty much, yes. Right now, the flexibility is not there. The moment you do publish, it goes and creates those web services instances and all that. But that's where I want to create, give the flexibility of either creating a GI endpoint or not. So once you have the GI endpoint, you can go talk to the nodes and get the results. If you don't even want that, you should be able to do that without that as well. For example, if WAC extension is my only target of retrieving the results or the only way of retrieving results, I don't even need a GI endpoint. I can actually go directly talk from WAC to the target nodes and get the results. So it should be possible maybe in future.
And additional question, are you thinking about adding some additional sources or destinations for the events? Because right now you have the events in JSON.
Yep.
And for example, putting them into event log.
Yep. Yeah, so question again is, sorry, that's 45 minutes. Okay. Right, so the question is there a way or is there any plan to add more test result destinations? Today it's a JSON file on the local file system. The question is, can we kind of have another source or another destination for those results? Very valid question, and I think like you showed in your session where you're forwarding events to a central system, I think we can pretty much do that. So that's the kind of a flexibility I'm really targeting, right? Any point within the entire engine or the framework, you should be able to branch off and do something else, right? Like publish, like he was asking, you should be able to use a different configuration management system to publish the tests onto the remote systems. Reporting, multiple options, and for even test result collection also, not just JSON, but we should be able to write event logs and then forward them off to a different source, etc. Sorry, that's the chakra. That's the powerful weapon. Yep. Anything else? All right then. Don't forget the feedback in the app, and that's thing about me. Any other questions? We will be happy to take here. Cool. Thank you.